Welcome to Intergenerational Politics, a podcast that makes politics engaging and relevant for all generations. This is Victor Shi, a freshman at UCLA and the youngest elected delegate for Joe Biden.
And I'm Jill Wine-Banks. I am the author of The Watergate Girl and also the wearer of Jill's pins. And today's pin is very special for our guest. I don't know if he can see it so clearly. I'm going to try to get, he's shaking his head.
I see it completely.
So okay.
Nodding my head. Yeah, shaking would be left, right. I'm nodding.
So for all of you who are listening rather than watching, it is a planet. And maybe he can even tell us which one. It's one with a ring around it. But it's
There are 4 planets with rings, but the most famous of those 4 is Saturn.
Oh,
So,
okay.
but you're the sphere in the middle of your ring is kind of an aqua blue.
Yes, it
Generally,
is.
we think of the planet Uranus as being sort of an aqua blue, and Uranus has a ring. So if you want to be totally geeky in the exchange, nope, it's not Saturn. Yeah, you thought it was Saturn, but it's not. Yeah, you can go
That's
there.
what I would have guessed, but I'm glad to know from an expert.
For sure. So today we are ecstatic to be joined by Neil deGrasse Tyson, if you couldn't already tell. For those who don't know Neil, which should be no one, he is one of the most famous and influential astrophysicists to ever live. He is currently the director of the Hayden Planetarium at New York's American Museum of Natural History and a prolific author and communicator. He hosts the podcast StarTalk and hosted 2 seasons of Cosmos, televised by Fox and National Geographic. Neil has also received 21 honorary doctorates, which is 21 more than I have or most people do have, and NASA's Distinguished Public Service Medal.
Our goal today is to get to know Neil, his latest book, and his ideas. But I want to start with a fun fact in trying to get to know Neil. Neil was born on the same week that NASA was founded, which makes him seem to me like somebody who was set in the stars to be who he became. It was definitely aligned with the stars. And another fun fact is that for my high school science project, I made a papier-mâché solar system. That was it. So somehow we're related, Neil.
Well, Jill, I bet your solar system also had Pluto in it.
It did.
Okay. Today, no self-respecting elementary school kid would put Pluto among the other planets.
Yes, it did. It definitely did. And Mars was red. And anyway, it was quite an accomplishment.
Excellent.
It was more a mechanical accomplishment. But today we also are talking about Neil's newest book, Cosmic Queries, comes out today, March 2nd. We are honored Neil is joining us for his first interview about his book, a book everyone will enjoy reading. In it, Neil offers to take us on some of the biggest, most fascinating questions facing our universe, such as, how did life begin? What is our place in the universe? Is there life elsewhere? And he does it in a way that we can all understand. So thank you, Neil, for being here, and congratulations on yet another book.
So I'm delighted. Thank you. And just in the very warm introduction that both of you shared of me, I just want to comment that, Victor, for you to say that my 21 honorary doctorates are more than you have. If you had any doctorates at this age, that one would have been amazing. Okay, if you're a freshman in college, there's still a lot of life ahead of you to earn whatever you want. So we're not disappointed in you for not yet having a doctorate. I just want to make that clear.
So, and I'll bet Victor doesn't know that it's 20 more than I have.
Okay.
Oh.
Okay. Yes. Anyway, given that I use brooches, Jill's pins, to send messages, I also wanted to do another fun fact, which is, although you're not wearing a tie today, you do have a background that could be similar to some of your ties. You seem to wear mostly very carefully selected ties to send messages related to astrophysics. And I heard that you have 110 cosmic ties. Am I right?
Yeah, it's about that, plus another half dozen vests. And generally, it would be a fashion no-no to wear a cosmic tie and a cosmic vest, unless they match each other, and very rarely would they match. So if I'm wearing a cosmic vest, it's a solid color tie. And if I'm wearing a cosmic tie, I'm either with a solid vest or no vest at all. Just because I don't want to offend fashion sensitive people out there.
Right, right. I just have to tell you that my husband has for a tuxedo a vest and tie that are Dalmatians. So it is possible
Ooh.
to find matching sets.
So I'm not trying to signal anything. In
Not.
modern language, I think they call it dog whistling, right? No, it's just that in men's fashion, maybe it could be changing as we go forward, but historically in men's fashion, there weren't many options to express oneself. Cufflinks, maybe, or tie clips. And so the necktie becomes one of the only ways I can just sort of wear my profession, if you will. And I have three. Can I show you a couple right now?
Oh,
Just
Yes,
if,
yeah.
oh, we'd love
if you're,
to. Yes.
you've donned your pin, and so yes, I'm not wearing these now, but I'll show them to you in sort of a sequence. So again, there are those who are only listening to this podcast, but here's one I have. The tie is fundamentally black, but
Yeah.
on it's got no end of illustrated cosmic objects, planets, moons, stars, and some are in exquisite detail, others are small and sort of lower resolution.
Wow.
But they're all different colors. And the advantage of this tie is because there's so much stuff on it, that you could spill spaghetti sauce on it and people just think it's another nebula, or something. So it's a highly versatile tie for all eating situations. So this is one I have if I know I have to eat out with some dignitaries or something. I've got another one, which is also a busy tie. It's also black. But the difference here is it's not as much stuff on it. There's still planets and moons, drawn almost in a cartoonish sort of way. The difference here is this is hand painted. And so I have a subset of my ties that are hand painted by an artist. And so I value sort of any time the universe has touched the world of the artist, because then the artist absorbs it and then it becomes part of culture. All right. I don't think anything can really be part of culture until artists have decided that it's that turn for it to show up. And one last one, just to show you, I do have some classical taste. This one is sort of an old, almost like a woodcut engraving of the sun and the moon, each with a face on it. But imagine a sun and moon with a face in some woodcut from 300 years ago or 400 years ago. That's what this is. And it has the moon moving in front of the sun. So in fact, this is an eclipse, if you will. It's what would happen in an eclipse. The only thing that's not true is that real eclipses, the sun and moon are not smiling at you.
And
This is
Donald Trump isn't looking at them directly.
that's three of my 100 and something ties.
Wow.
So
Wow.
can we start with I know it's your podcast, but I have a question of you. If you're politically
Sure.
exploratory in your content, how often does everyone just agree? Yeah, that's what it is politically, and then just move on to the next topic. Because political debates, I've always wondered if the people on the stage can't convince each other, why should we believe any one of them should convince the rest of us? All right. If the argument is not good enough to convince, I say this only because in science, if I'm debating a colleague, one of three things is true. Either I'm wrong and they're wrong and I'm right, or we're both wrong. And we enter that knowing this. And and at the end, we always go out for a beer after, right? Enemies are not made when you disagree on topics, especially when the solution might be, okay, we need more data. Okay. And then you go out and you go have the beer. So I'm just curious, what hope do political podcasts ever have other than to sort of feed the people who already agree with you?
Well, let me take a shot at answering at least part of that, which is I suppose it depends on who your guests are. And I have been on MSNBC shows where, for example, on one occasion, I was with Jenna Ellis, a name that some of our listeners may know as one of Donald Trump's most recent lawyers in perpetuating the hoax of election fraud. we did not come to agreement. We came closer to fisticuffs than agreement. And that's because I deal in facts, just as you as a scientist do, and she does not. So how do you come to agreement when you're not talking facts? But I'd say, first of all, that Victor and I, despite the difference in our generations, tend to view things pretty similarly, although there are a lot of times when his questions will be based on being 18 years old and wanting to know what the future holds. And so we do bring slightly different perspectives. I also do a podcast called #Sisters-in-Law, which is with my fellow MSNBC legal analysts, Joyce Vance, Barb McQuaid, and Kimberly Atkins. And the three of us, or the four of us, the three of them and me, pretty much agree on almost everything, but we all bring a different perspective to it so that we enrich the discussion and educate each other and hopefully our audience. And I think that on podcasts particularly, the people listening already agree with you. So you're not really trying to change their mind, although Victor and I and the sisters-in-law all speak in terms of facts. So we do hope that people will be better educated and will be better able to argue with people who do not agree with us. Does that make sense to you?
Yeah, I think so. So you're you're taking the high road there, which is whatever is your view. If I can summarize, whatever is your view, there could be nuances and elements and other dimensions you haven't considered that will enrich your understanding even of your own views and could open you up to new views.
Absolutely.
Yeah.
Yes. Yeah. I definitely have an open mind, and I learn. Our guests on this podcast have been extremely informative to me. I learn from every single one of these, and I take away from it a new sort of way of looking at things. And one of the things we do want to talk to you about is critical thinking. But I think first, let's start with, if you could, we want to focus a lot on your book, your new one, Cosmic Queries. So let's start by having you tell our listeners and viewers its general overall theme.
Yeah. So my podcast, StarTalk, which is now in its 12th year, actually.
Wow.
And it was in the early days of podcasts, and it predated that as it was on terrestrial radio and then satellite radio. Now its largest audience is via podcast, streaming podcast. It's the format of that program is bringing science to people, but most of the time not interviewing scientists. Okay, you say, well, how does that work? Well, the traditional model is the journalist has a science program and they invite scientists and you have the conversation. So, well, who's going to tune into that? These are people who already know they like science. Okay, so how about the people who don't know that they like science? Or even better yet, the people who know they don't like science. How do you get to them? So we thought we would invert the model. And the host, instead of being a journalist, would be a scientist, that's me. And I interview all manner of people, politicians, performers, comedians, singers, songwriters, dancers, and they're the guest. And the show explores all the ways science has touched them in their lives and manifested in their livelihoods. And that way, you, as part of their fan base, if you're a fan of these people, you're following them wherever they go, right? Whatever they are, you're going to follow them. And now they're talking about science. And what we found is that for many people who are out there in pop culture, many of them have like a geek underbelly, okay? I'll give you an example, just a fast example. Interviewed Josh Groban, okay? Jill, I don't know if you know who Josh Groban is.
I do.
Victor, do you know who Josh Groban is?
I do not.
You do not? Okay. Okay.
There's the generational difference.
Not only generational, it's also significant gender gap there. So I asked him, what % of your audience is female? And he said 110%. Because 10% of the, you could remove 10% who are female, there's still 100% left. There's a gender, he sings love songs, all right? And so I said, well, tell me about, when you were a kid. Were you a geeky kid? And he, in high school, for his science project, put mirrors on the surface of a woofer, of a speaker cone, mirrors on it, and then aimed lasers at the mirror, and the laser reflected onto the ceiling. Then he played music through those speaker cones and watched the laser points dance on the ceiling.
Wow.
Whoa.
It's just, yeah. So who else is he going to tell that to? What interview could possibly have that be a centerpiece? Well, that came out in StarTalk. So what we do is we try to bring science to the public through the lens of pop culture. And my co-host is always a comedian who's a force of levity in the show, in the program. If the content is a force of gravity, the comedian is a force of levity. And it's not a comedian who just knows one-liners. Did you hear the one? No, it's a comedian who is perceptive. And as you surely know, comedians, they are the sociologists of our generation, right? They see people, culture, things, objects, trends, and they have to know it well enough to then give it back to you so that you'll then laugh at it, right? This takes significant talent. Well, so we've got comedians as part of the formula, dare I call it that. So make a long story short, or to answer your question, one of the spin-off formats of StarTalk is called Cosmic Queries, where I'm just there and I might bring in an expert on a topic that we solicit, and our fan base asks us questions. And it is a runaway success among our formats because they get to participate in ways that historically, so Victor, in the old days, radio shows were live. And you could call in, you'd pick up a phone, you would call in, and your voice would be in the airwaves. Is that amazing? Is that okay? So
it's unheard of these days.
So we just solicit the questions, and then we read them on the air and we answer them cold. I mean, they're not pre-rehearsed, so it's very candid and very fun. Some questions were very deep and have strong philosophical implications, and we said, "My gosh, let us collect those and make a book out of it." And so thus was born our second StarTalk book, and it's called Cosmic Queries. And it's got 10 questions, some of the deepest questions anyone has ever asked, ever. Like, what is it all made of? How did it all get here? How will it all end? What does it all mean? And so the book is infused with the scientific understandings of these questions and answers, and where necessary, we actually step into the philosophical implications of what those answers are. So thanks for asking about the book. That's what's in it.
That is fascinating. And having read the book, it does explore all of those questions, and it does so in a way that we can all understand. And I'm wondering for you, what first inspired you to write books? Because this is, I don't know how many books you've written so far, but I know it's a lot.
Yeah, it's a few. It's a few. I'm going to answer your question in what could be an unsatisfying way, because you asked a very clean question. What motivates you? And so first of all, when I was in graduate school, I wrote a column for a monthly newsletter, and it was a question and answer column on the universe. And why did I do that? Because they paid me to do it. You want a noble answer here? No, I was paid initially $25 for an answer. And then the fan base of that grew, and I was able to say, no, I need more. And I got it up to like 35. And I think in the final years, I was getting $50 an answer. And you do a few of those a month, that's a couple $100. And as a student, that was significant money. And so that's why. But then I collected enough of those. I say, hey, how many of these I got? I've got, so maybe that's a book. So I stapled it together. Of course, you got to, make it flow and do the rest of this. So the top edit on that. And then that was my very first book. That column was under a pen name called Merlin. And my first ever book was called Merlin's Tour of the Universe. And I'm happy to report, although wasn't the subject of this podcast, that my very first book is coming back into print in a year. And
Oh.
so it's Merlin's Tour of the Universe, updated, of course, but that's the idea and the concept. So that's why it began. Then I get my first job, really, okay, and I noticed that Natural History magazine. I got a call from them that said, "Oh, do you want to write a column for us?" And I said, "I don't have time for a column. I don't want to. I maybe, all right." And so I wrote a column for Natural History magazine for 10 years. 10 years, damn near killed me. Oh my gosh. Okay. What is the famous quote about writing? I don't enjoy writing. I enjoy having written. Okay. The act of writing is arduous and it's a pain but it's, hey, I like that. So the act of having written has significant joy to it, provided you put in the effort to make it work and flow. And okay, so 10 years of a monthly column at 2,000 words a column, that's a lot of content. That column has become 3 of those books. Okay, now another book, I had written op-eds about space, about NASA, about our past, present, and future, on launches and all of this. And I said, that's a book. So I culled all my speeches and my thing, and I got editors to help. And so that became the book, Space Chronicles, Facing the Ultimate Frontier. So it's that I'm writing constantly. And then I wake up one day and I say, I can put that together and make it a book. So in the case of Cosmic Queries, that one came outright as its own thing because I enjoy answering questions. Mm-hmm. Let me say that differently. It's not that I enjoy answering questions. I enjoy watching people feel more enlightened today than they were yesterday. As an educator, that's just a marvelous feeling. Yeah. To have that effect on people. And so that's why I enjoy doing the Cosmic Queries format for StarTalk. The Cosmic Queries book is the expression of this, and I have deep roots in the question and answer format that goes way back. But in this book, it's not just question, answer. Whole chapters are questions because they are the kinds of questions that not only deserved significant attention, but needed it in order to do justice.
Yeah, and those questions are really rooted in the premise of curiosity and exploration. And you write at the very beginning of your book, this is the introduction chapter, the last full paragraph. And I hope that you don't mind reading this first paragraph for us. And it's all about curiosity and wonder and kind of why you wrote that book. So,
okay, I can do that.
Sounds good.
I got it right here. Put on my old people glasses, and let me see if I can read here. Clear my throat. Okay, here it goes. Should I use my narrator voice? Which voice do you want for this? My planetarium director voice?
I think both voices are amazing, or all your voices are amazing.
What's funny is I've yet to visit any planetarium anywhere in the world where the director had a high pipsqueak voice. A pipsqueak voice coming out of the sky. I don't know. Maybe we're overdue for that. Just for the diversity of it. But the voice from the heavens. Oh. Okay, so here it goes. Cosmic Queries will feed your curiosity with the deepest questions anybody has ever asked about our place in the universe. But these pages will also dip you into the eddies of our uncertainties and dangle you by your ankles above the gaps of our knowledge. Why? Because therein lies the true source of curiosity and wonder. The not knowing, coupled with its only antidote, the need to know, empowered by the methods and tools of science, applied to the cosmic frontier. Wow. That's from the opening.
Yeah, and so you mentioned curiosity and wonder and the need to know, kind of just explore these questions. And to me, it seems like the questions that you ask in your book, so like, what is the meaning of life, or the universe, it would daunt most people. Do any questions ever intimidate you to write about or explore?
No, you can't. Questions can never intimidate. Sorry, they can and they do, but not if you're a scientist. If you're a scientist, the questions are the currency of what you're doing. All right? The not knowing, you are drawn to the frontiers of ignorance. And if you are not comfortable with the not knowing, you need to take up another profession. And so, no, there's none. No, okay. So what could daunt me is, the answer to this question requires $100 billion machine. That would be daunting, okay? Because who's going to pay for that? All right, yeah, so some questions I don't even want to ask because maybe I'll never get the answer because we can't afford it, all right? But those don't count, I think, in the category that you're thinking. Any scientist, if they're active on the research frontier, are racing each other to the place where we are steeped in greatest ignorance. And we like it. By the way, this is an important distinction. Consider most religions, okay, in the world. Most religions, especially monotheistic religions, they're sort of framed around having answers for things that you didn't otherwise know or wouldn't figure out yourself. Like, what happens after you die? Okay, well, here's the whole explanation for what happens after you die. So now you don't have to worry about that. You don't have to wonder about that because the answer is there. And so many religions offer these accounts of the world that leave people in comfort with some belief about that unknown. And I've had direct encounters with people where they say, well, what was around before the universe? By the way, we address that in the book, but they say, what was around before the universe? And I say, I don't know. And they say, well, there had to be something. There must have been God. And then, okay, if you want, okay, I'm not going to stop you. But the invocation of God in that moment brings calm to the person rather than abject ignorance about that point in our understanding of the universe. And I'm just simply saying, if you're going to run around and insert an answer that didn't come through experiment and observation and all the rest of it, you're just going to insert an answer and you're happy with that, generally you're not as good as a scientist in the laboratory.
That's fascinating. So how do you think someone can develop curiosity? Because that's a skill I think that you have, and most scientists do have that. But for just your average person, how do you think people can look at the universe and just ask these big questions and be as curious as you are?
It's not how do you develop curiosity. No, that's a perfectly fine question. What you got wrong is the assumption that somehow curiosity needs to be bred or grown or nurtured. No. We all have curiosity as children. In fact, as children, we are so curious. There's an entire dimension of how you raise children so that they don't die from their curiosity. Well, I have a paper clip. Oh, and there's a wall socket just at my height. Okay? I wonder, sockets are not at chest level to an adult. They are at ankle level, right where toddlers are crawling around. Right. So we have plugs to put in. Now, you don't have kids yet, right? We have plastic plugs that they're not nimble enough to pull out. We have to put gates so they don't explore steps and fall down steps. The knives are specially put away. Okay? So we think of this as kids just want to kill themselves. No. These are manifestations of curiosity. And it's all, what does this taste like? Oh, here's a toy, and this piece broke off. It looks like candy. Let me try to eat it. These are, to me, these are science experiments, but our culture treats them as kids being kids. But to me, it's kids being curious and exploratory about their environment. And so the task here is not how do you nurture curiosity, it's how do you preserve the curiosity that was there from the beginning. And somewhere between age 14 and 21, it's gone. for so many people. And the only thing that distinguishes a scientist from everybody else is that we still have our childhood curiosity.
So I have to follow up on some of the things you've said. One is my sister used a bobby pin, if anybody still knows what a bobby pin is, to put into a socket. So I guess now I'll have to see that as different than what I originally thought. She was just being curious.
Yeah, with electricity experiments, for sure.
Exactly. But I also, because of what you said about Josh Groban and the gender difference, and your conversation with Victor about questions, what I've observed is that women will ask questions, but men don't want to admit they don't know the answer, so they won't. And then after I or another female colleague will ask the question, I'll say, that was a good question. I was thinking I didn't know that, but they won't ask it because they don't want the boss to know they don't know. And have you observed that? Maybe among scientists that's not true, but certainly among lawyers and business people, that's what I've observed.
All right, so there's less of that in the sciences, but I've definitely seen it manifested. So, and it's a well-known phenomenon, but I interpret it differently. Yes, there's the guy, there's that guy bravado, and they can't be seen as weak society. I'm thankful that society's outlook on this is shifting. So, just not to go too much on an off ramp, but there was a period, I would say late 1960s into the 70s, where there was a series of songs, many of them from Motown, but there was a series of songs where the man was expressing emotion. These were love songs, expressing emotion, even to the point of tears. And they had to be asked, they were self-conscious about the tears. This is in the lyrics, okay? They're self-conscious. And one of my favorite songs is I Wish It Would Rain, okay? Oh, how I wish that it would. Go look it up. It was a chart-topping song. Well, why did the man wish it would rain? Because he was crying and didn't want anyone to see that he was crying. Okay? So I saw those 2 decades as transitional between the man who would never show emotion and would hold it back at all points, and in the transition to, I can't hold back my emotions, but I still don't want you to know it, okay? To a time where you just have men crying, okay? We had a member of Congress who, what's his name? They joked about him for his...
Well, Edwin Muskie got in trouble and...
Oh, got in trouble, right. But in recent... in the past 10 years, we've had... Boehner. Okay, why don't we go clean into that? So remind me of his name.
Speaker Bonner.
It's Speaker of the House, right?
Yeah.
So he would cry,
okay,
intermittently, and we had a head of NASA even cried, and now it's, a few people might murmur about it, but that's okay, all right? So my point is, the man expressing emotion, we do have emotions, but society made us keep it all locked up. And by the way, locked up emotion, I think we've come to learn, in the end of the day, is not a good thing, because it builds it builds up behind a dam, and then the dam breaks, and then you declare war on another country or something. But all that being said, and all that sort of psychology and sociological subtext, when I refuse to ask to get help, okay? In most of those cases, it wasn't because I was embarrassed for not knowing. It was because I wanted to find out myself. Okay, and so let me give an obscure example. Okay, I like browsing in wine shops. Okay, to see what wine is new, different regions of the world, different labels, different grapes, different pricings. And the salesperson would come up to me and say, "Oh, can I help you? What are you looking for?" And I'll say, "Well, there is something I'm looking for, but I don't need to find it right now, because if I find it right now, I stop browsing, right? All right. It's the old case of where in the days when dictionaries were printed on paper and you went to look for your word, you never went straight to the word. There was some other word that you hit. You'd learn 5 words for every 1 word that was your target. So the journey had value.
Yeah.
Okay. So the guy who doesn't ask for directions, it's not because, in at least some of the cases, perhaps most of the cases, it's not because he doesn't want to reveal his ignorance in front of a total stranger. It's that you learn, oh, this was not the right way. Oh, there's a a gas station here, or mini mart. Okay. And then now that person will learn more about that environment than if you just go straight to the destination. Mm-hmm. And so, bringing it back to the point of your question, again, sorry about those. I get kind of storytelling mode, and forgive me.
It's a great mode.
Good. Yeah.
But back to your question is when raising children, it's not ever about the answer. It shouldn't be about the answer. When your kid asks you, why is the sky blue? Or let me get something simpler. Why is, I don't know, why does rain sometimes snow? Okay? And you could say, well, it's cold out and it crystallizes. You can give that answer, but now the kid just has a question and an answer stapled together, and there was no journey between the curiosity and the resolution of that curiosity. And it's the journey where you will learn most of what you will ever know in this world. And so when our kids asked us questions, unless it was something really simple, just because you just dispatched with it quickly, for most of the time, I said, let's find out. Okay, and you do an experiment in the kitchen, you find a book, you try to mimic it yourself, you do all of this, and then there's way more substance behind the learning than simply attaching an answer to a question. Mm-hmm. So that's how I view curiosity, because the world is not simply about answers.
Okay, I like that answer. And
by the way, there's a German poet, Rainer Maria Rilke, has a beautiful poem on curiosity and other related subjects. And one of the lines that I've just never forgotten, it might be the last line in the poem, is, learn to love the questions themselves.
I think your book does that. And another thing your book does is it uses tweets, which I think helps to contextualize and reframe a lot of questions that are otherwise extremely complicated. And it does it in a way that makes them digestible and makes your book readable for everyone. So was that your intention in using tweets? Or
yes, thanks for noticing that. Yes. Yep. So the book is speckled throughout with tweets of mine over the past 6 years. I was early on Twitter. Mm-hmm. Actually, I've been on since 2009. But the tweets are inserted in places where it relates to the content. Okay, and there's many, because I'm an educator and I'm an academic, and my tweets are not just, oh, who's seen the movie about, no, I try to be educator when I tweet. So the tweets are not, it's not a stretch for there to be tweets in the book. But what the tweets offer, I think, it's for people with shorter attention span. Okay, let's say you hit a page in the book and it's like, man, this is longer than I thought, and just a little bit ahead on the road there's a tweet. So the tweets are like these little biscuits, your rewards for getting through some of the challenging portions of the book that get very deep and very. There are no holds barred in the book. When you got to answer the question, we got to, and picking up on the theme we just discussed, I think the chapters themselves are more celebrations of the question that spawned the chapter than they are answers. yes, there are answers in there, but reading through it, I think you end up celebrating the fact that such a question existed in the first place.
That's okay. That explains it to me. And in terms of explaining and being an educator that you are, um, can we just, as background for the rest of this conversation, have you define some of the concepts that, or at least the most important terminology that's in the book? Because I think it'll help our audience understand if we talk about, for example, the difference between the cosmos, the universe, the galaxy, the solar
Oh yeah,
system.
sure, thanks. So let's start small. All right, there are these things called atoms, which the Greeks named, and by atom in Greek means indivisible. They imagined that everything had this smallest piece out of which it was made. We would later learn, of course, you can break atoms apart, and atoms have electrons and a nucleus. And then you can break the nucleus apart into its particles. And those particles can be broken into parts. And we think we've hit the limit there. And so the particles that comprise the particles that are in the nucleus, those are called quarks. A fun name, and we describe where they came from. It was a playful, literate physicist who got the word quark from Finnegan's Wake, a James Joyce novel. So the book goes in the way we do in our podcast, where there's a pop culture reference, we're on it. It's because you bring pop culture as a scaffold to anything. That's why it's called pop culture. Right. And if I can link something to it, we're on it. Right. And that way you'll remember it more, and it'll stick with you more securely when I clad something to a scaffold you already constructed yourself. So we go from quarks, and they make up protons and neutrons. We've all heard of those. Right. That's the nucleus of an atom. The atom is surrounded by clouds of electrons. Other atoms can attach to these atoms by virtue of forces among the electrons. That's how you get molecules. We are made of molecules. So are most things we interact with in life. We feel light energy from the sun. Light is in the form of photons. Pho as in photography, photons, not to be confused with protons. Okay, so photons travels with light. And by the way, there's a fun joke. A photon checks into a hotel, and the bellhop says, "Well, do you have any luggage?" And the photon says, "No, I'm traveling light." These are geeky jokes. I don't know if you get these in your circles, but we get these geeky jokes. So the universe is filled with matter made of these atoms and molecules, and energy, not only in the form of light, but there's heat energy and kinetic energy, other kinds of energy. Oh, then we found out, wait a minute, there's other kinds of light. There's like infrared and ultraviolet and X-rays and gamma rays and radio waves. And visible light is not the beginning or end of it. It keeps going. And in modern society, we have exploited these bands of light for great effect. Microwaves to heat our food, to communicate with our satellites, and radio waves. They're less common today than they were back when everyone had TVs and portable radios. Radio waves and infrared, that keeps the French fries warm for hours at McDonald's, right? So we have exploited these other bands. Okay, we got that. Then we look around, we find, wait a minute, everything we know and love is only 5% of the universe. Who ordered that? We discovered dark matter and dark energy, two drivers of cosmic phenomenon that we can measure them, but we don't know what they're made of. And we have top people working on it. And so this book takes you that entire range of how the universe manifests itself to us. And and a lot of those words are familiar. You might not have seen them in the context of how they matter scientifically, but you've heard of microwaves, you've heard of infrared, you probably have heard of dark matter and dark energy. I bet you've also heard of the multiverse. That's in there too. Okay, as you ascend from atoms up to the largest scales, are there scales larger than the universe itself? And we take you there too.
Okay, and you also take us to some very deep questions, including let's talk about our place as humans in the universe or in this massive system.
Yeah. So, I mean, we like, if you ever see a list that humans have ever made that compares us with every other living thing in the world, we put ourselves at the top of that list. Okay. We say, well, we think abstractly. And, let's value things that think abstractly. Oh, there we are at the top of the list. Let's value things that can imagine the future or count or have math or philosophy. We're at the top of the list. When we even pose our questions in search for alien intelligence, we say, let's find other intelligence out there. Built into that very question is the assumption that we are intelligent. Well, who measured that we are intelligent? We did. So to an alien, maybe we are to aliens what worms are to us. And they would never even think of us as intelligent. Maybe that's why we've never been visited, because they've looked at Earth and they say there's no sign of intelligent life on Earth. Let's keep going. Okay? So one of the things a cosmic perspective offers you, the reader, is that really what it is in the bigger picture? Mm-hmm. Or has your hubris, your ego, redefined it in such a way that you end up looking better than you deserved in that comparison? So what's our place in the universe? Yeah, we are complex chemistry, okay? But so is a single cell, complex chemistry. So is a polar bear, a mouse, a butterfly, okay? Have you ever looked at any insect under a microscope? Oh my God, we've got the eyeballs and the hairs and the legs and the thing, and we're saying, but we are at the top. What? Top of what? What are you saying here? So it's important to keep that in context when you understand who and what we are in this universe. So that's important. And by the way, when you have that perspective, a cosmic perspective, it makes it harder to take up arms against other people.
So
I would think.
Yeah, for sure. And so my freshman year of chemistry, my teacher played one of your videos, and it's called The Most Astounding Facts. And you share with us how the universe is within us. And you also explore this in your book. You talk about how the universe is within us. What do you mean by that?
Oh, yeah. So a whole chapter in the book is, where did it all come from? Mm-hmm. All right. So and I remember asking this of my chemistry teacher in high school. And I went to a geeky high school, right? The Bronx High School of Science. Uh-huh. So this is a geeky place, all right? And by the way, I have to just, that high school has eight Nobel laureates among its graduates.
Whoa.
And so I don't mean to brag or anything, but I have to put that out there. So it is possible to have a system that can nurture creative scientific thinking. And 7 of those are in physics, 1 in chemistry. So I asked my chemistry teacher, where did these elements come from that we're made of? It's the carbon, the nitrogen, the oxygen. He says, oh, well, they're in the Earth's environment, and some other ingredients are just, and on the periodic table, and others are just in the Earth. And I was not satisfied that, because Earth had to come from somewhere, right? This is where you get the origins problem, all right? Things that have origins, you only get origined once. And then you continue beyond that. So what was around before the Earth? And he wasn't really equipped to answer that. And later I would learn, not much later, that our atoms were forged in the cores of stars under very high temperature. And this fusing of light elements into heavy ones releases energy, and that's what drives the energy budget of all stars in the universe. Mm. And as they make bigger and bigger atoms, they fill out the periodic table of elements. And then the most massive among them explode, scattering this enrichment across the galaxy, out of which our planet and us, we are made. And so to say we are in the universe, that's true. But it's also legitimately accurate, scientifically accurate, and even spiritually deep, I think, to declare that the universe is in us, even alive within us. And so it's these kinds of perspectives that are full up, legit, scientifically derived, but when applied to the human condition and the human sort of sense of the world can be way more meaningful to you than simply thinking about science as a tract of facts that you either take or leave or ignore or walk around because you never did well in science class. You don't have that option to just discard it or to step around it, because it is infused in everything we do in everyday life, and it will shape the future of civilization whether we like it or not. So we'd best become better shepherds of the power that knowledge of the physical universe gives us, so that we can ensure that our subsequent generations of humans can be proud of the foundations we laid in these times, rather than embarrassed by our short-sightedness.
Yeah. And I remember walking to that chemistry class, and that was the first video that the teacher played. And I think it was good that she played that video, because every Wednesday she would do this thing called like Wonder Wednesday. And you were the first video. And after watching your video, I remember being completely mind blown about chemistry and just loving the course. And I think it was because of that video. It was just mind blowing to watch.
Well, thank you.
Of course. So I want to shift more into your book, which is there's one person that you talk about, which is Galileo, who made scientific advancements, but in a way that challenged conventional scientific wisdom. Can you talk about what Galileo did and kind of how he did challenge conventional scientific wisdom?
Yeah, just to be clear, I want to distinguish pre-Galileo with post-Galileo. All right? So there are things we call science before Galileo, but it was not conducted in any way that resembles the way science was conducted afterwards. All right? So, yeah, you can go far enough back and people thought Earth was flat and we're in the center of the universe. There was a lot of thinking that went on, but at no time was it really turned into active practice where you would say, let me test my idea. And to make sure I'm not biased, let me get someone else to test my idea. And so that didn't really happen until 1600 and onward. Around the time of Galileo and Francis Bacon, a philosopher and scientist, also both of them wrote on the need to experiment. So what I'd rather say is Galileo bucked the trends of the Catholic Church, the thinking trends of the Catholic Church, itself based on Aristotelian logic, itself not the product of scientific experiment, okay? Aristotle is on record for saying, heavy things fall faster than light things in proportion to how much heavier they are. So if you have something 10 times as heavy, it'll fall 10 times as fast. It doesn't take a grant from the National Science Foundation to do that experiment. And Galileo famously wrote of this experiment, a light cannonball and a heavy cannonball, and they both fall at exactly the same rate from the tipped Leaning Tower pizza. He probably didn't actually do the experiment, but it's a great thought experiment, and you can do that experiment, and basically it's true. We're not talking about dropping a feather and a hammer. We're talking about two things of like density, so two cannonballs. Point is, he was showing that what you thought was knowledge from the ancients right on up to the day before he was born, is not the kind of scientific knowledge that would be established thenceforth. So I just want to put that out there. Yeah. So in modern times, you don't have the case where there's experimental evidence that something is true, and then later on find evidence that it's not true. That does not happen in the era of scientific experimental inquiry. What can happen is you have some ideas. We're still testing it on the frontier. We don't have enough data yet. You think it's this, I think it's that. We debate. That all happens, okay? But the moment experiments and observations come in and they get verified, that's in the books. You could improve upon it. You could say, what we thought was the whole story, there's a bigger story out there. So here's that circle that we just experimented on, but there's a bigger circle that this embeds into. Whoa, that's deep. That's Newton's laws growing to become Einstein. Okay? Newton's laws fail. But they don't fail in all the places we tested them. They failed in new places that we couldn't test before. And we needed a deeper understanding of the universe. And you know something? When you put in low speeds and low gravity into Einstein's equations, they become Newton's equations. So Newton grew into the Einstein understanding. So with Galileo, the problem there is you had a philosophy embedded in a system of power that had power over you, and that was the power of the church. The church was the state, basically, okay? And so he says something that conflicts with authority that has as its foundations things that are not based in experimental evidence. That takes courage to stand up against that. Right. And he did.
Do you have any predictions?
He's an example to us all.
Yeah, for sure. Do you have any predictions for the future? Because Galileo, one of his most, I guess, known kind of experience was taking this telescope and looking into the universe. Do you have any predictions for what the future of looking into the universe will look like? You mentioned a few in your book, like the laser interferometer space antenna or the James Webb Space Telescope. What would that look like?
Yeah. So the good thing about my field is because so much of it is hardware driven. Okay. I know we're not going to know whether there's life in Jupiter's moon Europa, which has an ocean of liquid water beneath a frozen layer of ice. We're not going to know until we send a probe. Okay. So when we send the probe, and if it's designed to look for that, I'm all in, and let's get ready for that discovery or not. Okay. So there are checkpoints in our future where we know to look for things. And if you look for things in advance of that, we're not ready for you yet. Okay. So what I look forward to are new kinds of telescopes that are not just based on light, photons. Okay. So the Laser Interferometry Gravitational Wave Observatory, LIGO, is looking at gravitational waves that are caused by stupendously energetic phenomena in the universe, like colliding black holes. We now have a telescope to detect those. I'd like a telescope that detects neutrinos. You got to read the book to learn about neutrinos. It's a kind of particle that lives among us, all right? But they're very hard to lasso. And when you do, they tell you things about what's going on in the universe, opening up a whole brand new kind of window into what's going on. So I lose sleep at night wondering, are there whole windows we don't even know are there? Then we get to, oh, by the way, there's a window here. Can you open it? No, I don't know how to open it yet, but I know there's a window. Okay, then we figure out a way to pry it open. Now, do we know how to look out the window? No, I need special tools. Okay, but then you finally do that. Oh my gosh. What are we theorizing about the universe today that could benefit from some whole other place that we're not looking? Some whole other window on the universe. So gravitational wave, is there a dark matter detector, a dark energy detector, a telescope? Who knows? So I'd lay awake at night wondering what the future of those discoveries will bring.
Mm-hmm. And I think it's because of that exploration that we're able to get so much new scientific and technological advancement. And one thing that you mentioned in your book, which I'm curious to hear your take on, is whether human intelligence should always lead to technological advancements. In other words, do you ever worry that the rapid increase in technological advancement may pose more harm than good?
So the way you asked that question came with an assumption. And the assumption was a technology is itself inherently dangerous. As opposed to asking, I'm taking you to task on this, as opposed to asking, are we wise enough as humans to harness the benefits of future technologies without bearing the cost of its mismanagement? That's a different question than saying we should not invent new technologies because the technology is bad. That's a different question. And so let me just say, given recent times, I was on Colbert March 6th, 2020. Oh. Okay, the whole country shut down a week later, all right, from the COVID pandemic. He asked me, I'm just sitting there in the studio. He says, what do you think about this virus, this thing? And I said, it's paraphrasing myself because I don't remember my exact words, but it was something like, This is an experiment on whether society will listen and heed the advice of scientific and medical professionals. It's an experiment. That's what this is. It's a shot across our bow. And no, we didn't. No. I give us a C plus at most. All right. And most of that C plus is the effort to create the vaccine in record time. Okay. That boosted it from an F. Okay. But otherwise, I can't. So, yeah, we should not be in the technology business if we don't have people responsible enough, especially people in charge, responsible enough to use it as a force of good rather than as a force of evil.
Yes, I'm glad that you took me up on that. That makes a lot more sense.
So I changed pins in your honor because you talked about atoms, and so I'm now wearing an atom pin for anyone who is watching this on YouTube or following me on Twitter. I will post both pins.
Very cool. And I don't know if you know this, but the U.S. military, if you die and if you're buried in a military cemetery, you can say, well, what do you want over your grave? And if you're Christian, many people will have a cross. That's very common. If you're Jewish, you have the Star of David. If you're Muslim, you might have the sickle, the star with the crescent moon, and not the sickle. The
Yes.
star with the crescent moon. But suppose you're not religious at all. You can actually choose to have that atomic symbol over your grave.
Really?
Yes.
Oh my gosh. Okay.
Yeah.
All right.
It looks just like that, minus the colors.
Mine's a good color combination.
Yes, yeah. I wasn't dissing your colors. I was just saying it's carved in stone. So
Yeah.
All right. This could be me in the future someday.
all right.
Let's get back to your book. And to return to the book, I wanted to ask you to read from page 189, the second paragraph, and then we'll talk about that.
Oh, that's deep in. Okay, well, let's go there. Let me put my old people glasses back on. Okay, here we go. All right. Simple paragraph.
Not a simple paragraph.
Okay, sorry. Short paragraph. Thank you. Every living thing on this planet operates with the same chemistry governed by the DNA molecule, which starkly indicates that we're all descended from a single progenitor cell that appeared in Earth's oceans billions of years ago.
So now everyone listening can know why I said it's not a simple paragraph.
All right.
It's a dramatic concept. So I'd like to hear more about that.
Oh, really? Okay. I'd like that it piqued your interest deep in the book and you pulled that out. So we think of life as requiring DNA because all life we've ever encountered uses DNA. So we can ask the question, if there's life on another planet, would it have DNA? Must it have DNA? We want to sort of break free of the shackles of Earth bias. It was hard enough to break through the shackles of human bias, but Earth life bias, that may be hard, if not impossible. What we do know is that all life forms on Earth not only have DNA, but we have DNA in common that's traceable to microorganisms that we have very good evidence began in the ocean. And so liquids are good for chemistry experiments because things can move and readjust and change, and you can have stable environments for long periods of time. The environment can change, and sometimes the change triggers a change. The change in the environment triggers a change in the organism, or in the next generation of organisms. So the ocean is a rather fertile place for any of this to go on. So the point is, we all have DNA in common with a banana. Okay, something like 40%. I forgot it might be as low as 20%, but it's not near zero. All right, it has to do with the sort of the metabolism of the plant life relative to our metabolism, and the sugars that are in a banana relative to the sugars in our bloods, and how it gets processed chemically. These are all instructions via DNA. And when you look at this, it will tell us that all life we've ever studied on Earth has some strands of DNA in common. Some you have to go a little farther deep to find those strands. So in other words, the less like the organism you are, the less DNA it has in common with you, but it still has DNA in common. That's how we know we're all descended from a single life form on Earth.
Wow. Well,
And by the way, if we go to Mars, we could find one of three things. Life is there and it has no DNA at all. That would be interesting. How does it encode identity and features of survival if it doesn't use DNA to do so? That's one possibility. Another one is it has DNA, and it has DNA that's in common with strands of our DNA. That would signal that we might be descendants of Martians. As weird as that sounds, it's not completely weird. Early universe, there were asteroid strikes. If Mars had a layer of life covering it because it once had liquid running water, and then you have an asteroid that hits it, kicking rocks off the surface, floating through space, landing on other planets such as Earth. If you had stowaway microbes in the nooks and crannies of that rock, Mars can end up seeding Earth with life. And the point of common DNA would be very deep in the DNA strand as you looked for it. So that's another possibility. A third possibility is it has DNA and there's nothing in common with us, which would tell us that maybe DNA is an inevitable consequence of complex chemistry. And we are not descendants of Martians, or nor vice versa. They have their entire own lineage and tree of life, native to that planet.
Wow. Okay, that is definitely a big concept. And it reminds me of two things which may not be related, but both from museums in Chicago. And one is the coelacanth, the fish that time forgot. And the other, which is related to that in a way, is an exhibit that Chicago had on the origins of life and showing, for example, a skeleton of a bat that looked exactly like a human skeleton, slightly different proportions. The wings are held out by much longer arms than a human arm would be, and it has fingers at the end to spread the wings. So is that all part of this, that we share DNA, so it's not a surprise that the bat looks in its essential form?
Yeah, so it goes deeper than we simply share DNA, is that bats are mammals. Mammals are their own branch on the tree of life. So you would expect there to be extraordinary similarities among mammals, because mammals came relatively late, within the last 100 million years, out of billions of years in the history of life. So that branch has fundamental things in common. You could also say, we all lactate, okay? Forget what it looks like. What is it we do? We lactate, okay? Oh my gosh, no other animals lactate. That's an entire DNA instruction that occurs and unfolds and manifests among mammals. Mice, what makes mice so interesting, first, they're about the same size as small bats, right? Bats, the body of a mouse and the body of a bat.
Yeah.
I'm not talking about the big fruit bats, but a lot of the other bats. So they kind of look similar, okay? In fact, there's a Mozart opera, The Fledermaus.
Yes.
Is it the flying mouse? Or it's a bat. It's a bat, okay? All right. So mice have so much in common with humans. They are ideal laboratory animals, test animals for medicines, for so many things. Mice have obesity. They have drug habits. They have, we don't want to think that we are so different from them. We don't want to think that way. But that similarity is extraordinary, and we have exploited that fact in our laboratories. So yeah, you'd rather experiment on a mouse than on a human being, unless you want to protect all life on Earth. And then you're saying, well, why are you only protecting the fuzzy life and not the ones that are not fuzzy? Or why are you protecting the ticks, for example, and the mosquitoes? If you unpacked many people's urge to protect animal life on Earth, it's often they've pre-sifted it for things that they have judged they wanted to keep and not. And we're doing our best to completely eradicate a virus from this pandemic. Okay? What about the virus? The virus wants to continue, right? So we are being very selective, and understandably so. I'm not criticizing that. I'm just stating that if you come here as an alien, you're saying, oh, they're protecting these life forms and not others. Why? Oh, well, these hurt them and the others don't. Okay, let's understand that, but don't pretend like you're good for all life, because you're not. And if you're a vegetarian, you're eating plants. Okay? The plant, I'm sure, wants to live, okay? But now you're eating them, and that's kind of weird. All right, imagine a life form from another planet where they're entirely covered with photosynthetic cells. So they don't eat anything. They don't kill anything to eat. They just absorb sunlight, and that's their energy source.
Wow.
What would we look like to them? We'd look like the most barbaric life forms they've ever imagined. We would be the stuff of their horror movies. We eat other animals. We eat plants. We eat anything that's alive. Because no matter whether you are a vegetarian or meat eater, you are killing things to eat. There are only two exceptions. There's milk and honey. You can eat milk and honey without killing the source of that. But everything else, you are killing something to eat, no matter what your diet is. But I don't see people thinking that way, and that's fine. But just don't pretend you're high and mighty. That's all.
So do you think there are forms of life elsewhere?
I'd see no reason why not, given how quickly life on Earth began, given how common the ingredients of life are across the universe, given how old the universe is, given how many stars there are, given the frequency of planets that we now have evidence to support what was previously a hypothesis, that planets are common. Put all that together, the ingredients, the time, how quickly life began, how old the universe, but put it all together. If you're running around saying life on Earth is the only life in the universe, you really don't have a reason for thinking that unless you have deep theological requirements that the universe is here just for us. Then you would not expect life elsewhere. But then you're not invoking scientific arguments to say that.
Okay, so let's move to the end of your book, because we want people to read this book, and you don't want to give too much away. But you also write, you offer a few, I guess not depressing, but almost depressing to read about, doomsday scenarios like a volcano eruption or an asteroid striking the Earth, and that could be the end of Earth as we know it. How likely are any of those going to happen, at least in our lifetime?
So first of all, those the doomsday chapter, if you will, how will it all end? You're just talking about Earth in those two examples. That chapter keeps going. Okay, how will the sun end? How about our galaxy? How about the universe? How about the very fabric of space and time itself? There's one of the emergent hypotheses from quantum physics and relativity is that the expansion of the universe will become so severe that it will rip the very texture of the fabric of space-time itself. And you're worried about a volcano? How selfish of you. Okay, this is the whole universe you should be worrying about. So we were talking about super volcanoes there. By the way, Earth will survive a volcano and an asteroid strike. When people say save the Earth, no, they really mean save humans on Earth and save life on Earth. Earth, the planet, it doesn't care. If Earth gets hit by an asteroid, any asteroid that could hit us today, that's like a gnat flying full speed ahead into the side of an elephant. All right, the elephant is not concerned about this. And about super volcanoes, there are these places such as Yosemite, okay? And there are other places like in India, what they call the Deccan Traps. These are volcanoes that just spew so much lava onto Earth's surface and so much gas that it severely and catastrophically alters Earth's climate. Now, here's the perennial fight between astrophysicists and paleontologists. We handed you an asteroid 65 million years ago that catastrophically changed the climate. Oh, what happened a year later? All the dinosaurs are dead. Okay, not a year, it took a little while, but they're all dead. Well, the geologist said, wait a minute, around then, there was this supervolcano in India. which changed the climate. And so they spend their life looking down. We spend our lives looking up, and we have multiple ways to get rid of the dinosaurs. And maybe the asteroid triggered the volcanic eruptions from the shock. I don't know. Or maybe it's just bad luck for the dinosaurs. If one didn't kill them, the others certainly would have. Or maybe it required both. But in any case, the Yosemite is sort of the next candidate to blow. But we don't see, and I'm speaking from a conversation I've had with geophysicists, we don't see other tandem evidence that it's on the brink. When it's on the brink, it starts like when your tummy gets a little gurgly. You usually know a little time in advance, enough to get to the toilet to throw up, okay? There's usually a little bit of time there. And so we geophysicists are measuring the rum tummy gurgling of Earth's structure, Earth's crust and below. And so we would have some indication that bad things were going to happen. And right now, there isn't. And we have an episode of StarTalk where I interviewed one of these geophysicists. She was quite convinced there's nowhere in our lifetime. We're thousands of years away, at worst, from having a catastrophic volcano that will render us extinct.
Well, that's good to know.
Yes, so you can sleep tonight. Yes, okay.
Yeah, for sure. Well, I mean, I guess that takes me to my next question, which is, do you think, Trump got a lot of pushback for his creation of a space force? Do you think a space force is a good idea for, I guess, this administration to continue to pursue?
So a couple of things. First, I bet none of Trump's supporters gave him pushback for the Space Force.
Oh, yes.
That's my first comment, and that would be half the country. I would also say that many people who were just vehemently anti-Trump, which is almost everyone who wasn't pro-Trump. Okay, these are the divisions that we endured for 2020 and before, but it was especially magnified in the pandemic year. That what I would tell people is, typically people seated on the left, I would say just because Trump recommended it does not itself make it a bad idea. Okay, so try to separate this out when you're analyzing events of the nation. And the Space Force has been an idea for a couple of decades now. In fact, I was on a White House commission where we discussed it, and it looked like we didn't need it at the time because space was, by the way, it was a growing branch of the Air Force. And they didn't feel the need to spawn at that point. Is that the right word? Or to spawn or to wean? Whatever is the reproductive word I need there. They didn't feel that need, and so that was fine. But it was a natural question to ask. Why? Because the Army, for the entire Second World War and before, birthed the Air Force. So during the Second World War, it was called the U.S. Army Air Force. Okay? 1947, 46, somewhere around there. The Department of War, which became the Department of Defense, decided the command and control is different, the engineering is different, what you train in who you want to perform in an Air Force versus the jungles or that's different, and so let's make it its own branch, and they did. So the Army spawned the U.S. Air Force, and it just continued. Today, you wouldn't even question that, right? Of course, you needed an Air Force. So unless you're questioning the entire existence of the military. But if you accept the military as a given, today you're not questioning the existence of an Air Force. And I see the day arise where even the greatest skeptics of it would no longer question it because they would recognize the value and the need for such a branch of the armed forces.
Interesting. I want to circle back on something that you had said earlier about the end of Earth. So climate change, when we talk about climate change and how it's an existential threat, that's an existential threat to humans, not to
humans,
Earth, right?
Earth. Yeah. First, Earth will be here. Let me make it clear.
Yeah.
It's not an existential threat to our species. We will survive climate change as a species. It's an existential threat to the 10,000 years of civilization that we have built much of which is manifest in our farms, in the locations and the functionings of our major cities in the world, nearly all of which are on the water's edge, be it the ocean, be it the lakes or on rivers. And as you melt the ice in Greenland and in Antarctica, the sea levels rise. And you can run the calculation. If we lose those ice sheets, the water level will reach the left elbow of the Statue of Liberty.
Oh my God.
So you will, and it'll happen on a time scale faster than you can just pick up a city and move it. So the existential threat is everything we have built and care about that we call civilization is under threat.
Oh my God. Well, I have a bit of a random question now, and I want to share my screen. For those watching, you can see what the structure is, but for those not watching, it's a tardigrade, and Neil mentions it in his book.
It's the cutest thing there ever was.
Yeah,
it's also called the water bear. And if you see pictures of it, you say, "Oh, isn't that cute?" And it kind of feels like a cuddly bear. I mean, it's small, it's microscopic, but if the images of it, you want a plush toy made of it. Yes.
Yeah.
Yeah.
Why are these these plush toys so important?
Well, I don't like value judging things. I think all life is important in some way. We're all made it this far. You plus the tick and the mosquito and the oak tree and the lobster and the jellyfish, now sea jellies. We are all alive today in the year 2021. We are at the outermost branches of this tree of life. And Jill, I want to get back to you because you had mentioned the coelacanth, and I wanted to say something about that. The coelacanth is also alive today. Every one of us is equally as far away from the beginning of life as is each other. So to say one is more this or less that, we are all alive today, and that's all the tree of life cares about. Are you alive or are you extinct? Okay. So that tardigrade is remarkable because they're nearly impossible to kill. You can freeze dry them. You can heat them in boiling water. You can immerse them in acid. You can radiate them. And they'll just keep on doing the backstroke. Wow. And so you can ask, why would any life on Earth have the ability to survive that array of assaults? There's no reason for that to be baked into its evolutionary resistance. There's no reason for that. Why would it possibly have these capabilities? A very obvious answer is, of all of the microbes that were stowaways from Mars, the way evolution works is nothing adapts, by the way. Nothing adapts. What happens is in any generation there's variation, and everything that cannot survive dies. Okay? So nothing adapted. So if there was any variation in microbe that then traveled through space, and if that variation could survive the freeze-drying conditions of space, the high radiation conditions of space, the high temperature of re-entry, the low temperature, all of that, if you survive that, you're going to have offspring on Earth that has those properties. So the tardigrade is the best example we have on Earth of something that could have visited from space. Because it has all the properties that will enable you to survive a visit from space. And getting back to your coelacanth, the life form that time forgot, people are saying, oh, life evolves. No, that's not really true. The evolution takes place if there's some need for it, okay? If there's some need. So watch. So let's say something happens on Earth where everybody needs 6 fingers, okay? Well, and everybody else dies. Well, everyone with 5 fingers dies. The people who had 6 fingers, but it was surgically removed at birth, you still have the genes for 6 fingers. You end up surviving. Those that didn't want that to happen are walking around with 6 fingers. They survive. Now every offspring from then on are humans with 6 fingers on each hand. Okay? They can invent a base 12 counting system. That's evolution because something happened that's selected for the 6 fingers. If nothing selects for the six fingers, then the six fingers dies like everybody else, and the humans just keep going. The coelacanth, at the bottom of the ocean, where temperatures are stable and conditions are stable, there's no reason for it to have become anything other than what it is. It's working the way it is. The same with the cockroach. Not much change for millions of years. They didn't have to change. They're doing just fine, and they'll outlive us. Oh, but we're the top of the evolutionary chain, we tell ourselves. Look at any biology book published up through the late 60s, early 70s. We are the pinnacle of evolution. We are humans. Tell that to the condor that's flying over your head with its wings, okay? Oh, you need hardware to help you fly, okay? Gosh. Anyhow, just the hubris of humans knows no bounds.
Although it is argued that the coelacanth was how animals got onto land and started walking, that it had.
Okay, so I thought there was a different, I'm not up on all my latest animals and what did what first, but the animal that walked on Earth first, I don't think that was the coelacanth, but it's a very checkable thing. We all can go to the the Google shrine and find out. But the point is, all evidence suggests that life on Earth's surface came from life in the oceans. Yes. So you need a walking fish or something that had some rudimentary features. And if that was good for the fish, then variations in their next generation would select for that, and everybody else would die.
All right,
but I just want to disavow people of ever thinking that evolution is about adapting.
Yes.
Yeah.
Nothing adapts. You die. And the species, quote, adapts because one member of that generation happens to have a variation that gives it reproductive advantage under those new conditions. If the conditions aren't changing, there's no reason for you to change.
So let me ask you another question that is based on your book, but it's not so much what the book teaches or exposes us to, but the scientific process of gathering information and thinking critically, which to me is one of the most important things that's currently missing from the civil dialogue in America. And I've observed that as a lawyer, I got trained in a process of analyzing information and critical thinking. And it seems to me from when I worked at Motorola with scientists, with engineers, that they have some of the same critical thinking processes. So I'm wondering if, and particularly because you have a master class on this topic, what you could instruct us today about what's important about critical thinking and how to develop that.
It's a very sane question. Thank you for it. I would say yes. There's a lot of overlap in the critical thinking training. A fundamental difference, however, between the court of science and the court of law is that in law, and I don't want to oversimplify this, and you being a lawyer, you can certainly jump in and correct me if I've done so. In law, the truth is not determined by you. The truth is determined by 12 regular people, none of whom are lawyers, and likely none of them are scientists, based on how many times I was rejected for my attempt to serve on a jury. So so while trial by jury is an improvement over jury of peers, is an improvement over trial by jury of non-peers, presumably an improvement over trial by no jury, presumably an improvement over trial by ordeal, presumably an improvement over no trial, all right? They're all improvements. But the ultimate improvement would be, let's get people who are experts at analyzing data, and they will determine whether you're guilty or not, all right? If you're not going to go there, that's where the similarities between the legal system and the scientific community end. And so, because we will take our analysis of data right on up to the edge, where at the end of the day, we end up agreeing because sufficient data has been brought forth. Mm-hmm. Whereas as an attorney, you are paid to defend someone, no matter if they're guilty, that you are in their service. So you want to reduce it or get the charges dropped. You have other objectives than simply finding the truth. Whereas the scientist is really just trying to find the truth, and the truth could be hidden in nature in some way. And it is not, this critical thinking, getting back to your question, is not taught in the schools. It's got to be there. Not only that, you know what would even be better than just critical thinking? A whole class on how the human sensory system can fool itself. Because there are things you think are true that are not. And there are things you think that are not true that are. Do you have the capacity to figure that out? And the methods and tools of science are exquisitely conceived and designed to determine that. So, and right now, science is taught as just a satchel of facts. You're some empty vessel. Oh, here's what DNA is, and here's what an engine is, and here's the properties of a chemical on the periodic table, and here's the parts of a flower. We all memorize that. Do you still remember them? Are you a deeper thinker about the world for having memorized anything? Really, when it comes down to it? So something needs to change in the educational system to get us self-aware of our capacity to misthink things and to stoke the pathways of curiosity so that you're rewarded for asking questions rather than being rewarded for believing you know the answer.
Boy, I think that is the most important thing maybe that you've said today, based on my conversations with, for example, Trump supporters. And if we could teach a way in grade school for people to understand, exactly, it has to be immediate, to be able to absorb information and to analyze it, to determine, because you said one thing that I would disagree with, which is a lot of my career was in public service as a prosecutor. And we are taught that our only goal is to seek the truth. It's not to win the case, not to convict someone, but to determine the truth so that if someone is acquitted.
I never said that's not what you were trained to do. Yeah. Okay. I'm just talking about what actually happens in and you finding the truth is kind of irrelevant if you have 12 other people where it's their job to determine the truth. That I was talking about the system and how the system comes together in its puzzle pieces. Right. So yeah, and you have and another thing, your symbol is the Lady of Justice, right? And she's got the scales. She's got a sword. Why she's got a sword that always scared me a little, but okay. And she's blindfolded. And I think to myself, the eyes, they have some issues with the eye-brain connection, but still, I'd rather see something than not see it, if that's the case. So you're removing some senses. It's like, add more senses to it, all right? So I have these are issues. I don't want to lay them onto you, but yeah.
Okay, so I'm just motivated to ask one more question. It was announced that Rush Limbaugh had died and that Donald Trump had not only praised him, but said that until the end, Rush believed that I had won, as do I. I won by a landslide. How do you, when we're talking about critical thinking and fact and communication, what's the answer to that? What do we do with the fact that 74 million people, or some large percentage of that amount, believe what he's saying? How do we move on?
Yeah, so there's been a lot of focus on Donald Trump. And understandably so, he was president. But I never spent much time thinking about Donald Trump. If you look at my Twitter platform, I have a lot of followers, and many people with that many followers, there's a lot of sort of political, they're trying to get you in their camp, and there's none of that. I think I had one that even made backward reference to Trump. It had to do when he got his medical checkup, and he was considered in perfect health, and they gave his height and weight. And if he were 1 inch shorter or 1 pound heavier, he would have been rated as obese. So those two numbers were exactly in a place that contained him in a perfect bill of health. So I had my trainer take a picture of me with weights, and I'm his height, and I actually. I don't really believe his weight, but I gave my weight, my accurate weight, and I said, "Here I am," and I was like curling some weights, and all I said was, I'm this height and this weight. I wonder what the White House doctor would say about my health. Okay, that's all I said. And this just got people just going in and running the numbers. That's the closest I came to anything commenting about Trump. And even that was a dig on his doctor. Okay, here's my point. You can cry, complain about Trump forever. It doesn't change the fact that 60 million people voted for him even before all of this, that that the Trump haters hate him even more for knowing. Okay, and the second election, even more people voted for him than the first time. So the issue is not about the leader. The issue is about our fellow citizens. That's who it's about. It's always been about that. And so if you have an elected representative who thinks weird things about the world, chances are when you part the curtains, there are people who elected him that also think that. So for me, it's not about the politics. It's about the foundational learning of what goes on in the school system. We have to restore the trust in institutions, because without that, and restore trust in what is true and what isn't, without it, there is no functioning society. We'll just go by the wayside of the Roman Empire, right? It was great while it lasted, time for somebody else to rise up. And the surest way to unravel that is to have nobody agree on what is true. And it's sad. It's a sad but true thing. With regard to Rush Limbaugh, you may notice, and I can't claim that I've been a follower of his, but I've seen intermittent interviews and I know his personality and where he comes from when he speaks. In his later years, he did not badmouth scientists and technology. Okay, oh, it's evil and scientists. Why? Because they gave him hearing. He lost his hearing. I don't remember what was in his adult life as a broadcaster, he lost his hearing. And so they performed the medical surgery of putting an intracochlear device developed by NASA. Okay, it is NASA Technologies, where they go inside your skull, put electrodes that stimulate the part of your brain that would otherwise be stimulated by your eardrum. That gets converted into sounds that you hear that come through your ear canal, so that when you hear someone speak, you have to relearn what those sounds mean. But now you can still function as a participating member of society. He has one of those, and you can see it mounted on the side of his skull, and it goes around the ear. And so technology saved his career, basically. So maybe we need more demonstrations of what role science and science literacy and science discovery and the methods and tools of science, and what role science plays in searching for and finding what is objectively true in the world. Maybe we need more examples of that. Maybe scientists need a PR firm. It'd be sad, but maybe that's necessary. Without it, we might as well, as I continue to say, all move back into the cave.
Yeah, no, that was sort of the purpose of my question, was how do we communicate what is fact to the people who are listening to what is clearly fiction?
It becomes bigger fact when it affects them directly.
Right.
Yeah.
And so, yeah, it affected his hearing. He'd have to lose, he wouldn't have a job if he didn't have it. So Trump, I didn't know he said, so Trump is going over the cliff with that he won in a landslide.
He won yeah, exactly.
Okay. I mean,
exactly.
we shouldn't be surprised by that.
But that's what perpetrated the insurrection and the violence. And if he keeps on saying it, people will keep believing it. And I don't know how to combat that. And that's where I do critical thinking, and I read the backup documents. I don't just listen to somebody saying that. I look at, what are the election results? What did everybody say about it? But how do we get the 71 million people who voted for him to, in some way, analyze the information that he's feeding them? And how do we get them to understand that when he says it's a fraudulent election, that there is not a shred of evidence? There is not one single scientific data point that would support that.
So I don't have a silver bullet for that to reply to that. I can I'm pretty sure that some of the Trump supporters, I couldn't tell you what fraction, are just want him because he was Republican, because they don't want a Democrat. All right. And these are not the people who would embrace the mismatch between what he says and what is
Right.
otherwise objectively true. I don't know what percent that is. And power has a way of making the truth not matter. If by abusing the truth or changing the truth to what you want people to think is true, that if you end up staying in power, right? So I think it's not as simple as, is this true or not? It's, did they really not want Biden so much that they would go with someone who they knew misrepresented the truth? So if that's the case, what is Biden not offering these 74 million people that he could be offering them? Right? So there's a way to step back and try to look at the problem differently that may be necessary in the years to come. I'm remembering, was it a woman interviewed, was it on CNN early, before the first election, so this would have been 2016, and after more and more was revealed about Trump and how he treated women, they found some woman in, not quite rural, but definitely not suburban, and they go up to her and ask her, so who are you voting for? And she said, I'm voting for Trump, okay? And they said, well, you realize how he's treated women, and he's, and she says, oh yeah, I know all that. He's an idiot, but at least he's our idiot. And it was like, okay, there is no comeback to that. Yeah. Okay? There's no argument you're going to give her to have her not vote for Trump. And so there it was. We find out what percentage of the 74 million is that. Maybe they could be reached by other parties, be they Democrat or independent or whatever else.
Well, thank you for indulging me with that question. If we have just a little more time, there was a part that Victor would love you to read.
Sure.
Ask you a question about if we could just go to that, Victor.
Okay, and let me do that now.
Yeah, all right.
There you
go. So one last question. So you start your book by talking about your goal of cultivating curiosity, and you end your book by asking the reader to ask more big questions and be curious. And there's this one paragraph at the very end of your book, and I think that would be a great way to end the podcast with one last quick question.
Okay. All right. Thank you. All right. So here goes. Many questions about our own humble universe, perhaps just one of an infinite number of universes, remain to be answered. We implore you, dear reader, to continue to stoke your curiosity and to ask the impossible cosmic questions. For the goal of our short life is not to find the answers, but to search for new places to stand so that we can formulate questions not previously imagined. Along that journey, as you shape your own cosmic perspective, we bid you, as always, to keep looking up.
Wow. So I guess, to end the podcast, how do you think my generation, rising generations can continue to stroke curiosity, learn to ask the impossible questions, and then shape our own perspective?
Yeah. So I have two kids, slightly older than you, but I think you're in the demographics of it all, you're counted as the same generation. So I think a lot about how you think of things. And in that generation, I see more urge for social justice. I see more science literacy in your generation than in generations preceding it. It's maybe the first time ever that an adult said, I can't wait till the next generation takes over so they can fix the problems we created. Okay? Let me tell you now, there is no time in the history of civilization where any grown-up said that about the next generation. Just look it through, you'll see. So, in fact, there's some famous quote, was it on a Syrian tablet? It says, the corruption of the world abounds, and the youth no longer mind their parents, and it is clear that the end of the world is near. This is like 4,000 years ago. Somebody was complaining. So I would say keep on keeping on. I think what you're doing is you are trying to speak truth to power, not to overuse a very important phrase there. And I also think you're the first generation, I think, to really embrace people who are different from yourselves. I mean, look at protests. Who's leading the protests? Is it 50-year-old men and women? No, it's students in upper high school and in college, and just the entire LGBTQ movement. It's reaching new heights. It reached sort of slow early advances in the 80s and trickled after that. Great new advance. That's not led by the old guard. It really isn't. We're too tired. We're too old. We're too embedded. All right. It's the new guard. So I think that's important, because once you embrace all demographics, that's where new ideas come from, new discoveries, new inquiries, new perspectives on old ideas that can shape a future that we can all be proud of, rather than embarrassed to bequeath to our offspring.
Well, that was the perfect way to end the podcast. And we just want to thank you so much for being so generous with your time and spending time with us to launch your book today.
Okay, well, thank you. And thanks for your interest in the book and for digging out the questions. It was like, hey, yeah, that's a good section. I'm glad you picked that section.
Thank you so much. You've been very generous and so charming and wonderful.
Excellent. And guys, keep politics front and center, because it's, as much as I wish science ran the world, it's not. It's politics. Yeah. And so that's got to be out there.
But we use the tools of scientific thinking to help.
Yes. Excellent.
Exactly. We'll merge them.
Yes, exactly.
And Victor, good luck in school. Sometimes you need a little bit of that too. Excellent.
Hopefully next year in person. Let's get the virus under control so he can actually be on campus and enjoy the wonders of college.
There you go. You got it. Yeah. Okay, guys.
All right. Thank you so much, Neil.